Assalamu alaikum. My name is Samreen Zahra, registration number 21TE103. Today we are going to perform the lab number 4 of digital signal processing. So the main objective of this lab is to analyze the discrete time, linear time invariant system. So the question arises that what are the linear time invariant system? Linear time invariant systems are those systems in which signals are getting our output by adding the same delay to the input signal and we get the same output signal. So moving towards our task number 1. Task A. How would you differentiate between the signal and system? Explain the key characteristics of each and provide example to illustrate their role in the context of signal processing. So in this question we have to differentiate between the signal and the systems. So the signal is a representation of physical quantity that varies with respect to time and space. It conveys information such as audio, video, temperature, pressure, or any other measurable quantities. So in signals, we can use its representation. It has amplitude and has its frequencies. So the major examples of signals are audio signals and image signals. Now, what are the systems? System is a mathematical or physical entity that operates one signal to produce the desired output. It could be a simple circuit or a piece of a software or a complex network of interconnected components. So in systems, we can discuss input-output relationships, their linearity, their time invariance. And the examples of the signals are filters, amplitudes, modulators, and amplifiers. In task number B, the task number B says that how does linear time invariant systems play a clear role in the digital signal processing? Consider their mathematical simplicity, adherence to the superposition principle, and efficiency in the frequency response analysis. So, the linear time invariant system play a very important role in digital signal processing due to their mathematical simplicity. So, in mathematical simplicity, linear time invariants are characterized by their linear time invariant properties, which make them relatively easily to analyze and efficient, and they have efficient algorithms and technique to process the signal digitally. Adherence to superposition principles. LTI system follow the superposition principles, which state that the response of the system to the sum of multiple input system is equal to the sum of response to each individual input signals. This property simplifies the analysis of complex signals by breaking them down into the simpler components, making it easier to understand and manipulate them. So, and the last one is efficiency in the frequency response analysis. The LTI systems have very well defined frequency response that can be efficiently analyzed using the techniques such as Fourier analysis. This allows DSP engines to understand how LTI systems affect the frequency content of signals, and labeling tasks such as filtering, equalization, and modulation to be performed efficiently and accurately. Now, task number C, this is saying us that what are the common method of signal decomposition, specifically focusing on techniques like impulse decomposition, step function analysis, even odd decomposition, and Fourier analysis. Explain how these methods contribute to break down signals and their application in the signal processing. Common method for the signal processing include impulse decomposition, step function analysis, even odd decomposition, and Fourier analysis. Impulse decomposition. This method involves the decomposition of a signal into the sum of scaled and time shifted impulses. Each impulse represents a discrete event in the signals. Impulse decomposition is useful for analysis signals with sudden change of spikes, such as senescence data analysis or event detection in the time series data. Step function analysis. Step function analysis break down a signal into the sum of step functions, which represent a sudden change in the signal's value. Even odd decomposition separates a signal into its even and odd components. Fourier analysis decomposes a signal into the sum of sinusoidal components of different frequencies. That method provides an insight into the frequency content of signals and allow for filtering, comparison, and modulation of a signals. So these methods contributes to breaking down of a signal by providing the different perspectives on the signal characteristics such as sudden change in symmetry, periodicity and frequency content. Depending upon the specific property of a signals and the objective of the analysis, different decomposition techniques can be applied to extract relevant information and facilitate the signal processing takes efficiently. The task number D said what is the convolution and how it plays an important role in digital signal processing. Explore the fundamental concepts of convolution and elaborate on its importance in various digital signal appliances such as filtering, signal processing, and system analysis. So the convolution is basically a fundamental operation in digital signal processing that combines two signals to produce a third one. It plays an important role in digital signal processing due to its veracity and applicability in various applications. Fundamentally, convolution involves the overlapping of signals referred to as an input signals onto another signals and computing the integral or sum of their products as one signal slides or shifts relative to the other. In digital signal processing, convolutions have several reasons: filtering, signal processing, system analysis. In filtering, convolution is extensively used in filtering operation by convolving an input signal with the impulse response of a filter. The output signal is obtained. In signal processing, convolution is applied in the various signal processing tasks such as smoothing, edge detection, and feature extraction. And in system analysis, convolution play an important role in analyzing the behavior of linear time invariant systems. It allows the characterization of how a system responds to different inputs. So convolution is a fundamental concept in digital signal processing that enables the manipulation, analysis, and understanding of signal in various applications. Now moving towards task number E. Task number E is when do we correlate two signals and what are the key applications of scenarios where signals correlate is critical in various fields such as communication system, radar and sonar image processing, biomedical signal processing, control system, wireless communication and seismic signal processing. Signal correlation is performed when we want to measure the similarity or degree of correspondence between the two signals. This operation involves multiplying one signal by time shift version of other signals and then integrating or summing the result over time. So the key applications are key applications in communication system, radar and sonar image processing, biomedical signal processing, control system, wireless communications are as follows. Communication system, signal correlation is used for synchronization purpose. In radar and sonar, signal correlation is used for target detection and tracking. In image processing, correlation is used for template matching, where a template image is correlated with the larger image to locate the instance of the template within the larger image. In biomedical signal processing, correlation is used for tasks such as event detection and analysis. For example, electrocardiography correlation techniques can be used to detect the abnormal heartbeats by comparing recorded ECG signal with the normal heartbeat templates. In control system, it is utilized for system identification and modeling. By correlation, input output signal system parameters and dynamics can be estimated, facilitating the design and analysis of control system. In wireless communication, correlation is used for channel estimation and equalization. And in seismic signal processing, correlation techniques are used for earthquake detection and localization. So signal correlation play a very important role in various fields. Now moving towards our MATLAB task. In MATLAB we can use convolution for the linear time invariant system. So now task number one is about making our own customized functions that can take two input signals from the users and show convolution sum graphically. So this is the example here. Firstly, we can define the convolution sum functions, and by using the different subplot commands, we can get the graphs. So in the command window, we can set up two signals. The first signal is 1 2 3 and 4, and the second signal is the same 1 2 3 4. It will show us a graph like this. So this is the graph of convolution sum. So the graph number 1 is showing the signal 1 and this is showing the signal 2, and this is the convolution result of both signal 1 and signal 2. In task number 2, we can using our own customized functions that take two input signals from users and use flip and slide method to show the convolution sum step by step. So this is the example. Same, we can define a function of convolution step by step functions, and by using the convolution results and using the subplot commands, we can use using the subplot commands we can figure out our signals by using for the flip signals we are using this n is equals to 1 n plus m minus 1, and this for loop for the flipped signals the subplot commands are used, and pause function is also used. So in the output signal we can set up our same in command window. We can using the same two signals, that 1 2 3 4 is the signal 1, and same 1 2 3 4 is the signal 2. So this is the graph that will show the convolution result of both signal 1 and flipped signal, that is signal 2, and this is showing the right flip, right shift, and then find the perform and then get our required result. In task number 3, we can compute the response of the following system. So in this, h is equals to the h is the impulse response, and x is our required signals. We can use the command of n is equals to length h plus length x minus 1 for resulting signals, and we can perform the convolution by using the for loop, using the display command to display our required response of the signal. So this is the response of the signal, and this can also shown by graphically this can show the convolution response of the two signals, that are signal 1 and signal 2. In task, there is an example for about index response by adding the beginning and ending index. So see the example. In this example, we can set a function of my convolution. In my convolution function, we can simply make our signal and add its impulse response, and then this is the output. The output will show in the two windows. Like in step 1, when there is no required input, it will show the amplitude at value 0. Then after adding the impulse response, it will show the it will gradually showing the impulse response, and this will show the sample index value. So in task number 4, where we have an impulse response of a system, and we use to feed shift version of the input signals to take the signal. So in this task number 4, we basically want to see that which type of a signal will be received when we apply impulse response to our given signal. So when we add an impulse response to our given signal, and by using the convolution command, we can get a convolution command, and applying the shift toward the signal, we can get a required output graph that this is like this in the shifted version. So this is all about lab number 4 of digital signal processing. Thank you so much, and Allah Hafiz.